Alright, this video we're going to continue in some of the example about separable variables. So, okay, as you see that this we have dy on the left hand side. So we try to bring this forward here. We divide both sides by 1 minus y squared. So means that the dy, as the dy staying here and this moving here, is become 1 over 1 minus y to the power of 2, right? So we have done with this. So now we have dx. So we're moving dx cross, right? Dx, and this one is negative x over 1. So go over there, we become 1 over e to the power of negative x, right? So, and after we have separate the variables, we integrate the function. So, and we have to consider what formula to use for integration, right? So we must have a very good in different integration skill. So for example, this case, this is square, this is not a linear, we cannot use in ln. So what we can do is we just can bring it up before we integrate, it becomes negative 2 dy. And this is very simple, right? We can just bring it up, become e to the power of x dx. So we can integrate this by using a special formula. As this is a linear, we just add this by 1 and divided by negative 1 and the number in front of the y, which is negative 1, right? So equals to integrate ex, it's very simple, become ex plus c, right? So if we rearrange this one, we have negative 1 become positive 1. So we have 1 minus y to the power of negative 1 equals to ex plus c. So we just write this as a solution. This is a general solution for this differential equation. Alright, I hope you understand. Let's move on with the next example. Alright, okay, let's see how to solve this equation. So, okay, as I will just maintain this dy dx at this side. Alright, this side. And for this, I just bring it over, it will become negative x squared of x squared plus 1. So that now I try to separate, okay, as ey dy will be staying on the left hand side. And negative, you can multiply negative both sides. So they have no negative. So we have y ey dy equals to x squared of x squared plus 1 dx, right? So y ey dy equals to x squared of x squared dx. We have separate the variable. After we separate, then only we start integrating both sides, right? So then we have to consider, right, the technique of integration here. For this, as you see that, this will be you need the techniques of integration by parts. And for this, you need the techniques of integration by substitution, or you may use formula for these cases here. So I will show you using technique of substitution, and this is used technique of integration by parts. So let's for this side, okay, now for the left hand side, so we have u to be y and your dv to be ey dy, right? As you're very familiar with integration by parts, you know the choice of, you need to choose u and you choose dv, right? So for this case, your du will be dy. As you integrate this v, you integrate ey, you're getting ey, right? So, okay. And for the right hand side, I'm going to apply substitution. So I will choosing u to be x squared plus 1, the correct substitution method. So I will substitution function. So I will choosing u to be x squared plus 1. So because I differentiate, I will getting 2x, as I get du over 2 equals to x dx, right? So that it can be substitute and replaceable, means all the variable here can convert become u. Okay, now we solving this right hand side first. Okay, we divide this into right hand side and left hand side so that you have better understanding. So for here we have apply integration by part. Okay, sorry, is uv minus integrate v du. So u, right, y uv, right, uv. So ey minus we integrate v du du is dy, right? So which is equals to, right? So I try to complete this part first. So we have y, ey. Integrate ey, we have ey. Alright, so this is for the left hand side. We have applied the integration by parts. So whereas for here we apply integration by substitution, we can rearrange this as the x dx. If you see carefully, the x dx can replace by substitute by du over 2. So I have done with this. This one is replaced by du over 2. And for this, we have done with square root of u, right? U. So square root of u is u to the power 1 over 2, right? So integrate this, we have u to the power 1 over 2 plus 1 divided by this. If you add up, you're getting 3 over 2, right? Divide by 3 over 2, then you have du over 2. So you have 1 over 2 here. Have multiplied with 1 over 2 here. After integrating, you're getting 1 over 2 outside, right? So integrating this one, you have u power 3 over 2 over 3 over 2. Then we put a plus c here, right? As we already integrate everything. So now we just write y, ey minus ey equate to, for this we have 1 over 2 cancel off, right? 1 over 2, and we have u to the power of 1 over 2 plus 1, 3 over 2 plus with c, right? Plus c, rewrite, we have y, ey minus ey equals to u x squared plus 1 to the power 3 over 2 plus c. Alright, as this is the solution for this differential equation. Alright, let's move on for the last examples.